Okay, cool. At least I went through this. Now I came to the part where there are open questions or open like things that I basically need to work on. So the thing is, when we have state machines sending protocol messages, they also receive messages and update their database partition. So every possible database update is based on messages or is like a snapshot or a built-up version of all the messages received in the past and whatever those messages contained. So of course that's also characterized or internally represented by all our data structures and databases. They're boiling down to one or many hypercores, which are append-only logs that you can sync across the network. That's what the hypercore protocol is about. So what we need to think about is, first of all, which state machines can connect to which other state machines. Of course, inside of a node, every state machine in those processes, they can connect to each other because it's all controlled by the database owning node. But if a state machine wants to connect to a state machine, so if a state machine wants to a state machine inside one node's process tree wants to connect to a state machine in another node's process tree, which is another database, does it need to go through the root node, like some kind of an authorization logic, or can that just happen from within any state machine, but maybe there will be hooks that the node can check what kind of communication is happening between with other nodes. So that's kind of something that I need to think a little bit more about. And the other thing is, when we send messages from state machines to state machines, of course, there's some data in that message, but the idea is at that moment in time, when the message is sent or maybe received, but basically the snapshot of the local database of a state machine that is sending out messages, that particular snapshot could be like there could be like a read-only access token sent to the receiving state machines that live somewhere else. So they would then not only have access to their local state machine and to the message content, but could also read the content of the database of that state machine that sent the message. And it might even include further permissions to read even more internal database state of even more other state machines. And these are kind of the things that are a little bit tricky because it's important that in the end everything stays manageable, and a wrong decision could make things difficult to manage. So that's why I have to go through this. Otherwise, I think we are using currently XState for state machines, and Nina is quite far with implementing them. I have here like a more specialized or adapted to state machine notations adapted to our needs, but we might for now just use XState. And in parallel, we have some logic written for sending and receiving messages, but now integrating all of this together, that's important that we get like the architecture concept right, and based on this, get the details right. And that's quite complex to think through, which is why it's taking more time than I would wish it would take. Yeah, so that's my update, and I'll continue tomorrow. And yeah, I'll try to also then give some more updates soon. So yeah, see you tomorrow. Cheers.